All right, again, let's just read the information. Make sure the information given in the words is all in the diagram. OKL and CPQ are identical sectors. OKL, so that's this sector, and CPQ. Oh, okay, so that's just the top and bottom, right? So it sounds like the cross-sectional area is the same as we go all the way down. That might be helpful for the volume. I can already see that the volume of this slice of cake is the cross-sectional area times by the 3 here. Okay, so that might be helpful, all right? So that's these guys. The radius is 12 and the angle is 30. Well, yeah, 12 is written here. So I suppose this is also 12. And the radius of 12 here and also 12 here. The angle of 30 and 30 is given. That's good. Let me just go add some more 12 centimetres here. And a 12 centimetres here. And what else does it give us in the words? OKL is vertically above CPQ. All right, so that's just, yeah, okay. And all of these measurements are 3 centimetres. Yeah, so it's 3 centimetres here, 3 centimetres here, and 3 centimetres here. All right, so it's just saying to us that looks very much like a uniform cross-sectional area. All right, so let's get into it then. So calculate the length of the arc KL. So that's the length of this arc here. And again, from the formula sheet, I'm pretty sure it's got arc length is basically just a fraction, 30/3/60ths, of the full circumference, 2 pi r, right? So that would be just the formula. And again, reach for the calculator. Times by 2, times by pi, and times by r. So I've got a, let me put my pen back on. I've got 6.28 centimetres to 3 sig fig. And the area, okay, so the area of sector, again from the formula, is 30/3/60ths times pi times r squared. So we can go ahead and do that. Theta over 30 over 360 times by pi and times by 12 squared, and that is 37.7, again to 3 sig fig. When we go over the page, calculate the volume. So that was handy when I was discussing before. The volume of this is the cross-sectional area. So it's the area of like an end piece times by the height, which is the 3 all the way through. So we will need this 37.7. So volume equals cross-sectional area times by the height or the length, and that was the 37.7 times by the 3. And so I'll do it with my calculator. That's approximately 11323 sig figs. And finally, the total surface area of the slice of the cake. All right, so this is a little bit more challenging. Certainly I can see 2 of those green pieces of area, right? So that's 2 of those sectors. So isn't that 2 of these? Okay, so I'll put that first. So it's 2 of these. Right, times 2. And we know those are 37.7, so it's 2 times 37.7. Oh, 37.7, not 37.2. All right, let's go back to the picture. I think I can see a rectangle here, right? Isn't that a rectangle measuring 12 by 3? But then we'd have 2 of them, all right? 12 by 3, so 2 rectangles. We've got the 2 rectangles times 2 of those. So it's 2 of the 12 by 3 rectangles. We'll add that on. then there's a final piece, the tricky piece, which is this curved surface area. It's quite hard to see, but it's this. Can you see this surface area around the back here? Now what we can do is we can think of this as being a label, and the label of it is 3, and this little curved length here is the 6.28. And if we unwrap that, in fact, it just makes another rectangle. All right, and this rectangle here is 3, and this is the 6.28, because this length of this piece of paper, if you think about it as a label, is the same as this length and also this length on the bottom. So that's quite tricky, right? 6.28 times 3. So now we have all the pieces, 3 times 6.28. We just have to go ahead and put that on the calculator. So 37.7 times 2 plus 2 times by the 36 plus the 2 times the 6.28, and I get that as, well, to 3 sig fig is 160 centimeters squared, and again everything's been rounded to 3 sig fig, so that seems appropriate to keep that going at the end there. So that was a tricky last question for sure.